Okay, now this is going to get more complicated, okay? So what you have 4 times, there's no radical, then it's a 2 in the index, 2x times 5, radical 2 in the index, and 6xy to the second. So it's all multiplication with radicals, okay? So first thing you do, you make a radical, and it's the degree of the radicals are 2's, okay? Now you got to put something on the outside because you have 2 outside factors, the 4 and the 5, okay? 4 times 5 is 20. You put that outside the radical, or outside your parentheses, excuse me. Now we multiply inside. 2 times 6 is 12. And then we take x times x, which is x to the second. You just put ones and just add the powers when multiplying. And then y to the second as well, okay? So 2 times 6, x times x, and then the y to the second sits here. You got to pay attention to what's in there. Now we're setting up the 6 lines of doom. Okay, we won't have to do anything there or there today either. So the base is we have a 20 times a 12 times an x times a y. Okay, so 20 is to the 1, but that's not in parentheses, so that'll just stay a 1. You can just put 20 if you want. Now we go into the parentheses. 1 times a half is a half. 2 times 1 half is 1 whole, and then 2 times 1 half is 1. Use ABCs if you do really. Now, circle all your exponents, okay? We got 3 wholes and 1 with a fraction, so you put your wholes first. The 20 to the 1, then the x to the 1, then the y to the 1. Then you put your rational exponent, so times 12 to the 1/2 power. Now circle that bottom and see if you can get rid of that right away. I don't think you can because it's a 2 and 12 is not a perfect square. Okay, you don't see that, so you will not be just getting rid of it. So instead I jump down here, the ones with holes, the whole exponent. You just write those first. 20 to the 1 times x to the 1 times y to the 1. Now when we get to the bottom, you make a radical of a 2, and then 12 to the first is 12. Now you go through and simplify. 20 to the first is 20. X to the first you can write as x, or you can keep it to the first, and then y to the first would be y. Now I get to my radical. There are no variables in the radical, but I need to take my square root of 12 and attempt to simplify it into 2. Okay. Okay, so you're on your 2 list. You'd start at 9. Nope. Then 4. 4, 3. So you put the 2 out front and the 3 inside the radical. Now you do need to take 20 times 4. 20 times 4 is 40. Okay, so that is your answer. 40 times x times y times the square root of 3. Okay, now the radicals are of a degree 3. Okay, look in the radical, it's a 3. If you don't know if it's a radical degree, you got to ask me. I'm not the greatest writer in the world. So 1/3. So the first thing we do is take those outside factors, 5 and 2, and times those. That's 10, so we got a 10. Then we take 2 times 15, which is 30. X second, x fifth. You add the powers. That's x to the 7th. Then on y, 2 and 1. Okay, that's y to the 3rd. You add the power. You multiply the big bases, but on the variables, you add their powers. Okay, now this is what we're rolling with right there. That is not needed, neither is that. So you got a base 10 and a base 30 times a base x and a base y. Okay, 10 to the 1, but we don't take 1 times 1/3. It's not in parentheses, so it's just 10 to the first or 10. Then it'd be 30 to the 1/3 power. And x, you take your 7, right, circle the exponents as you write them. You take your 7 times your 1/3. That's 2 and 1/3. Now remember how to handle that. That's x second and x to the 1/3. And y, 3 times 3 is, 3 times 1/3 is 1. Okay. Okay, write your whole exponents. You got up 10 to the first. That's a fraction. X to the second. And y to the first. Now you put your fractions. 30 to the 1/3. Followed by your x to the 1/3. Okay, now circle your bottoms and see if you can slash those out. Now your radical degree 3, 30's not there, and the x sure as heck isn't going to be there. So now you jump down here. So you can't slash them out. 10 to the first, the ones with the holes you just drop down. Now you get to your fractions. They both have 3's, so I make one radical with a 3, degree 3, and then 30 to the first is 30, and then x to the first would just be x. You can put the x to the first if you want. Okay. Now simplify. 10 to the first is 10. X to the second, y to the first, you can just write that as y. Then the radical 3, remember you want to put your variable, just be x if it's to the first, and then you break up, attempt to break up your 30. Okay. Okay, you're looking at the 3's. So 30 divided by 27, nope. 30 divided by 8, nope. Okay, what do? You just put the 30 in the radical, you keep it like it was. Okay. If there's nothing to divide by, then you just don't do it. Okay, example 3. What's the radical degrees? They're both 2's if they don't have them. So it'd be a 1/2 power. Now we're not going to have anything outside because before the radical I don't have a factor and I don't have a factor here. So we just go start multiplying. So 72 times 10 is 720. X to the third times x to the first is x to the fourth. And y to the second times y to the third is y to the fifth. Okay, so now I have my exponent expression I need to simplify set up. So you have a 720 times an x times a y. So 1 times 1/2 is 1/2. 4 times 1/2 is 2. 5 times 1/2 is 2 and 1/2. Remember how that works. Okay. Okay, so put your whole ones first. Let's take this 2, put that. Take the other 2, that's a base of y. Now put your rational exponents. 720 to the 1/2 power and y to the 1/2 power. Now circle those bottoms. See if you know you can't with y, but how about 720? 720 is not here. Okay, and it's not first off, my list doesn't go that far, and it's not a square root. It's not a perfect square anyway. You see if you go 2 second caret 720, that isn't going to work. Okay, now, so instead we jump down here and we make that into a radical 2. You drop your wholes straight down. Then these two have the same denominator, which will give me a radical 2. That means I'll have 720 to the first, which is 720. And then y to the first, you can just write y if you want. So I can't simplify an x to the second or a y to the second. Now I get to my radical, and I put the variable y. But I need to attempt to see if I can break down 720. Okay. Now you start bunching 720, start dividing. So 720 divided by 256, you go all the way to the bottom, doesn't work. Divide by 225, doesn't work. Divide by 196, doesn't work. Divided by 169, doesn't work. Divide by 144, that does work, that's 5. So it'll be 144 and 5. So that becomes its 12. So I put it times 12 and then a 5. I cannot multiply here because it's just 12 and then x. Okay, next problem. The radicals are of a 4 degree. So first you got to look, you got factors outside. So 3 times 5 is 15. You put that outside the 1/4 expression. Then 2 times 32 is 64. X fifth, x third would be x to the power of 8. Y to the fourth, y to the first would be y to the power of 5. So you have 15 times 64 times x times y. So 15 to the 1, but it's still a 1. And 64, 1 times 1/4 is 1/4. On the x, 8 times 1/4 gives you 2 whole. And then 5 times 1/4, circle them as you write them, is 1 1/4. So you circle those separately. Now that's a whole, whole. So I write 15 to the first, then the 2, x to the second. You write your whole ones down first, then y to the second, because those are not rational. Now the 2 rationals I have are the 64 to the 1/4 power times y to the 1/4 power. Okay, now the ones, circle the bottoms and see if you can get rid of them. Go to your 4 list. Here's the 4 list. 64 is not here, so I can't just slash it out. So I just come down here. Okay, 15 to the first, you just drop no radical. No radical. No radical. Now you make the radical. They're both 4s, so I make a radical of a 4, and that allows me to get rid of the 4s, and it'd be 64 to the 1 times y to the 1, or just 64 times y to the 1. So 15 to the first is 15. X to the second is x second. Y first. Now you open up your radical. You put the variable, okay, y to the first, and then you break down the radical. Okay, we know it's not a perfect force, so that's why we're making it into 2 of them. So I'm on my force. It's either 16 or we're leaving it inside the radical. Work 16. 4. So you get rid of your 4th root of 16. That's equal to 2. So then you put it times 2 and a 4. Now I would prefer you multiply 2 times 15. That's 30. So it's 30 times x to the second times y times the 4th root of 4y. Okay, next problem. Now, instead of multiplication, it's division. It's a 2 still. Okay, so you make a 1/2 power. Now, instead of multiplying, you divide. Okay, you want to make a fraction here. Okay, trust me. 18 divided by 2 is a whole number. It's 9. You put 9 on top now. Okay. Then we minus the exponents. You cross out the one, the smaller one, 2. Now where's that x to the 2 at? It's on top. Okay. Okay. So I didn't end up with anything on bottom, which is perfectly legit. It's okay. Okay. So now I have 9 times x. So you divide the whole numbers, then you subtract the exponents. You cross out the smaller, take it from the bigger. Okay, 1 times 1/2 is 1/2. 2 times 1/2 is 1. Okay. So my whole exponent is a 1. Okay. Then I write my fraction. Now see if you can get rid of your fraction here, which I think you can, because if you go on your list of 2's, square root of 9 is 3. So now that's no longer a fraction, it's 3 to the first. Okay, so x to the 1, that's a whole. 3 to the first is a whole, so I do not make a radical. Okay, now you can simplify 3 to the first as 3. You're supposed to technically put the 3 before the x, but if you put x times 3, that's fine too. Okay, next problem. It's a 3, so we put a 1/3 power. Now you divide. Take 162 divided by 3. Now, if it divides into a decimal, you got to do something else. I do not believe that happens. So that's 54. You put it on top. Okay. Now, the y over the y, you get rid of the smaller y, and it's 3. Now, where's the y to the third at? It's on top. So again, we have no bottom. So you have 54 times y. A 1, so 1 times 1/3 is 1/3. 3 times 1/3 is 1. Okay, put the whole first. Then put the rational. Now, see if you can get rid of the bottom right away. You can't because 54 is not a perfect cube. It's not there. Okay. Alright, so I'm still there. Still rational. So I drop the whole. And now when I get to the base with the bottom, it's a 3, so I make a cubed root. That now takes the 3 out, and 54 to the 1 is 54. So y to the first would simplify into just y. Then I make my radical. And I don't have any variables in there, but I have to simplify my cubed root of 54. So make it into 2 cubed roots. Okay, at 54 you'd start at 27. Bingo, 27 and 2. Okay, so this is 3, and the 2's inside. You can't multiply anything outside, so there's your answer. 3 times y times the cubed root of 2. Or really, in a final answer in a textbook, the times dots wouldn't be there. Okay, 7. These are 2's. Now, just because they're both, there's 2 of them, that doesn't matter. Okay, multiplication and division, you condense it into 1. Okay, you're still doing the same thing. So I divide 50 by 2, that's 25, that's on top. Then we have x6, x4, so you get rid of your 4. X seconds on top, but we also have a y, and there's no y on top. So we just put y to the 4th on bottom, and it is on bottom. Okay. So when you line up your bases, it's going to be 25 times x on top with a y base on bottom. You're wondering why is on bottom? Because y to the 4th is on bottom. Then 1 times 1/2. 2 times 1/2 is 1. And then 4 times 1/2 is 2. Okay. Cross that out. Now you put your whole on top, put your whole exponent first. These are my powers. Put the wholes first. Remember to put the y second on bottom. It does not change its position. Then put your rational exponent. And circle the bottom. Now see if you can get rid of that, which I think you can, because it's 25 is right there, it's 5. So this is now 5 to the first, no longer rational. Okay. Now we're going to cross this out, but here's what this line is for. See that exponent that I have on bottom? It's a whole exponent, not a rational. Okay, so cross that out. Now if that's a rational exponent on bottom, you got to do a process called rationalizing the denominator. We get into that later. Okay, so all my wholes go first. So on top, x, these are both wholes now. Put your 5 to the first, and then your x to the 1. So there's no need for a radical on top. I got rid of the bottom the quick way. Y to the second on bottom, so there's no radical. Then 5 times x second, y second. Okay, last problem. Those are cubed roots, so you put a 1/3 power, and then you take 135 divided by 5, that's 27, it would be on top. Okay. Then x8 divided by x second means I take out the 2 and minus it. Remember, you're minusing when you divide, not adding. That's a 6. Then you still got the y, but that's on bottom, so we just put y12 on bottom. That means we'll just have a base on the bottom. So you got 27 times x and then y. 1 times 1/3 is 1/3. 6 times 1/3 is 2 whole. and then 12 times 1/3, 12 times 1 ABC3, it's 12 over 3, which is 4. Okay. No negative exponents, that'll change sometime next week. Okay, circle all your exponents. The whole, on top you got a whole, you want to put that first, then your fraction. Remember to circle the bottom, we'll look to get rid of that. Now bottom you have a whole. Now try to get rid of the rational exponent the quick way. 27 to the 1/3 power, that would be a 3. Okay, so I slashed it out and it's 3, so I got rid of it the quick way. Okay. We do have an exponent on bottom, but it's a whole. Okay. Alright, so on top we've got x to the second, no need for a radical, 3 to the first, no need for a radical anymore, and then y to the fourth. On top, you can simplify the 3 to the first. You're technically supposed to put the factor of 3. It's a coefficient, and then your variable. Okay. Then y to the